In this equation, or in this question, it asks about hydrazine. So hydrazine N2H4 is used in some spacecrafts as a fuel source. And we have an equation for that. I do want to highlight that there was a typo. So the typo in question is actually in this box over here. It gave you a gas instead of a liquid. So not much we could do about it now, but I just adjusted that in this table. So using the heats of formation, what is delta H reaction? So for this, we know that the sum of the delta H naught F of the products minus the sum of delta H naught F of the reactants equals delta H of the reaction. So this is pretty simple. So the trick is, it's not really a trick, the goal is to look at your equation. We know that it's going to be 2 of H2O gas plus 2 N2O gas minus N2H4 plus N2O4. And then you just read the values out of your table. So we have 2 times H2O with a gas, which is this one. You can see that the liquid is presented to you. So that's negative 241.8 plus 2 times N2O gas, which is 81.6, minus, in this case, we have the 9.16 of N2O4 plus 50.6. And when I plug this into my calculator, I get negative 392.76 kilojoules. And we should only have one place where it looks like 3 sig figs. So this should be negative 393 kilojoules is our final answer. So in this case, you would be provided a table. You read the values off the table, plug them into the equation. So the next question asks, or part B asks, what is the change in enthalpy if an F-16 engine uses 25 liters of hydrazine at 1.42 grams per mil? So what we need to remember is that this delta H really means that we have negative 393 kilojoules for every 1 mole of N2H4. So what we need to know is how many moles of hydrazine are we going to use? Because you can just multiply these values together. So I'm going to take my 25.0 liters and multiply that by 1.42 grams in 1 mil. Milliliters and liters do not cancel. So there are 1,000 milliliters in 1 liter. And then we need to convert grams into moles. And so hydrazine is 32.06 grams in 1 mole. And then I'm going to go ahead and multiply this by negative 393 kilojoules in 1 mole. So now all of these cancel, and that gives me a value of negative 4.35 times 10 to the 5th kilojoules. So basically, it costs a lot of energy because we used a lot of hydrazine. This is true in all of these, and it's part of why Hess's law works, because the amount of energy is proportional to the ingredients in the equation.